we'll skip section 2 because that method is a combination of the square root method, but it actually takes more time. We are not interested in that method. So now let's jump to section 3. And on your homework, you'll only see section 1 and section 2. There is no section 1 and section 3, no section 2. What we are going to do now we are going to learn a very, very important formula in mathematics. It is called using the quadratic formula method to solve any quadratic equation. So I highlighted this terminology here. What is quadratic formula? It's like a recipe. So this is a formula. We can just apply it to any quadratic equation. Before we start to know this quadratic equation, I want to go back to the very beginning of chapter 6. Actually, so when we first know the quadratic equation, we learned a terminology. It is called standard form of the quadratic equation. What is the standard form? So a quadratic equation means we have a square term of the unknown. That is called a quadratic equation. What is standard form of the equation? That is one type of equation, okay, one form of the equation. When we write the equation in this form, everything goes to the left side and they are sorted in order. So the standard form is still everything, all terms, they're on the same side. So that means we see 0 on the other side. And we'll have an order in the descending order of the x. So we got start with square term, and then we see what? We see the x term, and then we see the constant term. There is no x here. This x is, the power of x is decreasing. This is called descending order of the x term. If we rewrite the equation in this form right here, it is called standard form of the quadratic equation. And why we need to do this? Because we need to know the 3 constants, A, B, and C, what they are respectively. Then we will be able to use the quadratic formula. This is the foundation. Be able to rewrite the equation in the standard form and recognize what the A is, what the B is, and what the C is. And that's the foundation to use the quadratic formula. So what is A? A is the coefficient of the square term. What is B? B is the coefficient of the x term. What is C? C is the constant term here. So for any given equation, we should be able to write down the 3 constants. Quick practice here. So forget about the quadratic formula here. Given this equation, before we start doing anything else, let's write down the A, B, C. Okay, so step 1, if this is a standard form, the answer is yes. So this is descending order, and we see 0 here. This is standard form already. Now let's write down what A is. A is the coefficient of x squared term. There is no number before the square term. It means what? It means the coefficient is 1. So no number, we don't see a number. It means the number is 1, the coefficient. Now let's look at the x. So we see x here. What is the number before the x? There is no number, but there is 1 minus sign. So that means the number b, the coefficient of x is negative. So when we see a minus sign, we always give the minus sign to the next term. So this is 1 negative x is 1 term. What is the coefficient of x? Negative 1. And then the whole number right here, so this number, the constant term, c equals negative 4. Okay, so this is one practice. Now let's do a few practice here. Sometimes we are given an equation like this. Okay, is this a standard form? No. Why? Because we don't see 0 on the right. So that means we should move x to the left. And when we move x left, we should change the sign. X turns into negative x. Then we are going to rewrite everything in order. We can start with the square term, x squared. Then we'll see the x term. X now is moved. It turns into negative x. Then this constant 20 is still there. So minus 20 equals 0. Okay, rewrite this equation in the standard form. Now we are able to say it's very similar to what we just did. A equals 1, B equals negative 1, C equals negative 20. Okay, so sometimes we have to move everything by ourselves. Okay, move all the terms to the same side by ourselves. Another example. Okay, what we see here, sometimes we might, okay, if we want to use the quadratic formula, we will be, we are given this equation. So x, okay, 2x squared minus 5 equals 0. So if we are given an equation like this, and we are asked to use the quadratic formula, let's see how can we find out A, B, C, R. So, okay, if this is standard form, we see 0, and it is in descending order. So yes, this is a standard form already. Then we want to know, so what is A? A equals the coefficient of the square term. Then A should be 2. There is no doubt. Then we want to know what B is. Okay, so will the next number we see be number B? The answer is no. So B is what? So that's ax squared plus bx plus c equals 0. B is the coefficient of the x term. But for this equation, we do not have the x term. There is no x there. So we can picture this. So this can be seen as plus 0 times x. 0 times x still 0. 0 times anything 0. So 0 times x. So that means the coefficient of the x term, b, is 0 because x term does not appear in this equation, does not show up here. We just let the coefficient be 0. So just picture this in your mind. You don't have to write this down. There is no x. It means its coefficient must be 0. Then what is c? C is negative 5. So another thing I want to remember, a very common mistake. Some students do not like keep the minus sign in the term. So if we see minus term here, it belongs to the term next to it. So negative 5 is one term. That is the constant number in the equation. C equals negative 5. So after we know what A is, what B is, what C is, now let's go to the formula. I have the formula right here. And if you can, please start to memorize the formula, right? So what is the quadratic formula? The quadratic formula gives us the solution or the roots of a quadratic equation directly. So when we have a squared, so if we have ax squared plus bx plus c equals 0, for any quadratic equation like this, the solution x equals what? X equals. Okay, so let me highlight this. This formula I just highlighted, that is the solution of this quadratic equation. Let's look at what it is. So it equals actually a rational expression, okay, and a radical as well. So for the rational here, the denominator is 2 times a. So it's 2a is on the bottom. the numerator is what? Negative b. So negative coefficient of the x term. Whatever b is, we take the opposite, negative b, either plus or minus. There are two solutions. Square root of b squared minus 4 times a times c. See, this is one expression which has a, b, and c here. After we know what a, b, c are, we just plug them into the formula and then simplify. Done. That will be the solution. Okay, so let's see, go back to this problem right here. Solve this equation using the quadratic formula. Step 1, we have got a, b, c respectively. Now I'm going to copy. So at beginning, you might not be able to memorize the formula. You can just copy this down. Equals 2a, this is negative b, either plus or minus square root of b squared minus 4ac. Then we just do the plugging in. And 2 times a, what is a? A is 1. So 2 times 1 on the bottom. Negative, negative, we say b. What is b? B is negative 1. So negative b, negative, negative 1. B is negative 1. Okay, plus or minus square root of b squared. What is b? Negative 1 squared minus 4 times a 1 times c negative 4. See, you don't do anything else. Copy the formula down and then plug a, b, and c into the formula. What do we do next? Simplify this expression here. See, the denominator now, 2 times 1 is 2. Okay, and the numerator, negative, negative 1. Negative, negative turn into positive. So I get positive 1, either plus or minus. Okay, square root. And the square root here, we got negative 1 squared, that's 1. So 1, follow the PEMDAS rule. So if we just look at the inside of the radical symbol, we see a mixed operation. Follow the PEMDAS rule. Parentheses, exponential notation, multiplication, division. Lastly, we do the addition, subtraction. So this is square term, e, and then we do the multiplication. Negative 4 times 1 times another negative 4, negative, negative turns into positive. So plus 16. 1 plus 16 equals what? Equals 17. So that's negative 1 plus or minus square root of 17 over 2. Done. Final answer. If you like to rewrite it, that I want to see the two solutions. So that means the first solution, so x equals negative 1 plus, we keep the plus sign, plus 17, square root of 17 over 2. Or x equals negative 1 minus square root of 17 over 2. So make sure for this one, the radical 17 is a simplified version. We cannot simplify this, it stays like that. If we have this for this radical expression, we are able to simplify it, then we always need to simplify it. Okay, so that will be the two solutions for that equation. Let's see, well, do we have to know this? The answer is yes. Why? Because without applying this quadratic formula, we won't be able to solve the equation. See, we go back here, let's see, oh, let's see x squared minus x minus 4 equals 6. Think of what we have done in chapter 6. We want to factor the left side, but are we able to factor this trinomial? No, because there are no two integers exist to make sure their product is negative 4, their sum is negative 1. There does not exist the two integers, so we cannot factor it. If we cannot factor it, then we had to stop in chapter 6. But now, when we go to chapter 9, we know there is very powerful tool right here. The quadratic formula can help us to solve any quadratic equation, no matter they are factorable or they are not factorable. We don't mind. We just plug ABC to the formula here and simplify. We are able to solve the problem. This is a powerful tool, very, very useful. And the thing I want to share with you next will be this. Sometimes, all right, let's look at so x squared minus x plus 4 equals 0. Okay, for example, sometimes we are given an equation like this. Standard form already. We got a equals 1, no doubt. B equals -1, no doubt. C equals 4. So we know ABC right here, and then plug them into the formula. 2a negative b plus or minus square root of b squared minus 4ac. Okay, copy the formula down. Now we plug the three numbers into the equation, the solution here. 2a means 2 times 1 is 2. So for some simple ones, you can just skip some step. 2 times 1, negative b, take the opposite of b. So negative 1 is 1. 1 plus or minus square root. -1 squared, that's 1. Minus 4 times a is 1 times 4, that's 4. Then when we look at the inside of the radical expression, we got 1 minus 4 times 1 times 4. And that is so 1 plus or minus 1 minus 16 over 2. Okay, what is 1 minus 16? That's -15. So we'll end up with 1 plus or minus square root of -15 over 2. Okay, problem comes here. When we see a radical expression here, radical, and we have to make sure the radicand is always greater than or equal to 0. Then this expression will be a real number. This is called a real expression here. But here we see the radicand turns into a negative number. And then it tells us this equation does not have real solutions. So the solution, so this is not a real number because we cannot simplify radical negative number, -15. So, or the real solution does not exist. There is no real solutions. When you move on to a higher level math class, probably if you're in the STEM field, you will take the technical math 1 or 2. In the higher level math, you'll learn another type of numbers. We, in algebra, we have been dealing with real numbers. And in the higher level math, you'll see another type of number. They're called imaginary number. So real and imaginary, which is also called the complex number. In that case, you will be able to deal with a radical of a negative number. But for the algebra level, algebra 2, we'll stop here. When we see the radicand is a negative number, we'll stop. We don't have to move on at all. We'll see this equation, this quadratic equation does not have any real solutions. No real solution. That's it. Okay, so what we have here when we, my preferred way is this. So not always all the equations have real solutions. And when we apply the quadratic formula, this is what I used to do. My math teacher, when I took this class here, and she told class, step 1, write down ABC. And then step 2, no rush to simplify or plug ABC into the quadratic formula. We deal with the radicand. So this radicand, we can just use a symbol called delta. Delta equals b squared minus 4ac. This is an indicator. So we do not, jump to the quadratic formula. Instead, we just check the radicand. b squared minus 4ac. So we calculate what this is. So b squared equals negative 1 squared minus 4 times 1 times 4. And then we check 1 equals 16, it equals negative 15, sorry, equal. If this indicator, b squared minus 4ac, end up with a negative number that's less than 0, you'll stop. You really don't have to do the plugging into the quadratic formula. You can stop because this indicator, this b squared minus 4ac is a negative number. We can make the conclusion there is no real roots or no real solutions. You can stop right away. If the indicator, for example, so when we have this one, x squared minus x minus 4 equals 0, I get right down a equals 1, b equals negative 1, c equals negative 4 right here. I do this one. So check b squared minus 4ac first. This equals negative 1 squared minus 4 times 1 times negative 4, okay, which equals 1 plus 16 equals 17. If this is a positive number greater than 0, and then we can go ahead and plug them into the quadratic formula. So x equals with equals, so it means it has two solutions, 2a, negative b, plus or minus square root. And in this case here, you just directly plug number into 8. I know the radicand equals 17 already. And then you can just simplify this quick. You didn't actually lose your job. We will be using the work we have done here. The radicand equals 17. Plug the whole radicand to the formula. Right here, the b squared minus 4ac equals 17 already. Then just plug it into the formula, 1 plus or minus square root of 17. See, down. So to check this delta, okay, the indicator b squared minus 4ac, if it is greater than 0, you move forward, apply the formula, plug them into the formula. If the indicator is less than 0, you can stop right away. And another thing here, so not always the equation are given in the standard form. We have to be able to find ABC by ourselves. If we know what ABC are, and then if we know the formula, and then we'll be able to solve any quadratic equation. All right, so sometimes I want to give you one more. There's one more example here. For example, like this. So we have found out ax squared plus bx plus c equals 0. I got a, b, c right here. What do we do first? We check out, so b squared minus 4ac equals what? So we'll check this one. So b squared is negative 1 squared minus 4 times a times c right here. So this b squared minus 4ac equals 1, negative plus negative times negative turns into positive. 1 plus 80, that is 81. All right, so 81 is greater than 0. That means there are real solutions. Then I will use the quadratic formula. X equals 2 times a, 2 times 1, negative b. What is negative? B itself is negative. So negative 1, either plus or minus square root of 81. Okay, we just plug this delta into the formula, this b squared minus 4ac. Then try to simplify. So equals 2 times 1 is 2. Negative 1 is 1. 1 either plus or minus. What is square root of 81? I hope you recognize 81 is a perfect square number. 81 equals 9 squared. Square root of 9 squared, that's 9. So then we'll end up with two solutions. X equals negative 1 plus 9 over 2. Okay, negative 1 plus 9, that's 8. 8 over 2, that's 4. And then the second one is what? Negative, positive. what did I copied the wrong number. I just positive 1, that's 10. Okay, sorry, that's 5. I copied the wrong number. Positive 1 plus 9. The second one is 1 minus 9. So 1 minus 9 is negative 8. Negative 8 divided by 2, that's negative 4. So there are two solutions, 5 or negative 4. All right, so we did solve the problem using the quadratic formula. But I want you to go back to the equation. So do not ever forget what we have so far. We have learned so many different techniques, and we can choose the one which is the best to solve the equation. What is the best? The quickest one. So when I say the problem, so from now on, I have learned many different ways to solve the equation. But I never forget this one. When we are given the equation, right? So let me copy this problem. So x squared minus x minus 20 equals 0. Instead of using the quadratic formula, I always try to see, can I factor this trinomial or not? This is a leading coefficient being 1, a trinomial. I need to look for two numbers. Their product is negative 20. Their sum is negative 1. I know 4, 5 can give me a 20. 4, 5 can give me a negative 1. So I get x plus 4, x minus 5 equals 0. So this equation, the left side is factorable. X plus 4 times x minus 5 equals, then we'll get either the first one be 0 or the second one be 0. X plus 4 equals 0, x equals negative 4. X minus 5 equals 0, x equals positive 5. Down. See? Same answer right here, negative 4 or 5. Which will you like better? I prefer that method here. So it tells us from now on, when we are given any equation, we always rewrite the equation in the standard form. We see 0 on the right. Then we see, can we factor? If we are able to factor this, the left side, this is always the quickest way. If it is not factorable, then we have to use the quadratic formula. We can solve the problem. Okay, the quadratic formula will be the last way that we will try, because all the other methods, they won't work. Then that's how powerful this quadratic formula is. It can solve any equation, any quadratic equation. But this is not the easiest, this is not the simplest way, but this is the most powerful way. You can always use that one. All right, this is a shortcut. If we can use shortcut, why not? If the shortcut does not work, then we have to use the quadratic formula. Okay, so this is what I want to share with you for section 9.3.